Hi, in this video I will be demonstrating how to wire a day-night switch for your outdoor floodlight. In this video I will be showing the wiring connections, but I will also be going through the principle of operation of how to wire it, so that if you're faced with day-night switches that have weird labels, you'll be able to wire any day-night switch to any light fitting. This is an AC day-night switch and this is an AC light. This is for a single phase application. I will also explain the inrush current and also the maximum number of LED floodlights which can be connected to a single circuit breaker. Right, before I show the real life wiring, I'm just going to explain the principles of the wiring. We have a supply. Now a light or a load needs a live and a neutral. There you can see I've got a live and a neutral, and at the supply I've got a live and a neutral. So what happens is, from the output of the supply, there goes my live, goes into the day-night switch. The output of my day-night switch goes to my load. Notice that inside the day-night switch there's actually a relay. A relay looks like this. We've got an output side which controls the light, whether it goes on or off, and then what switches that on or off. You can see I've got a coil here, and that is controlled from another circuit. Right, so this is the day-night switch, and I'm just opening it up to demonstrate what I refer to. Here is the relay, and just over there, that is called an LDR, a light dependent resistor. When there is not enough light on the resistor, tells the transistor inside here to switch on the relay, so it shorts out two terminals. And when it does that, it actually shorts the live to the load. And that'll make more sense once I show more of the diagram. So back to the diagram, you can see we've got the live wire coming into the day-night switch, and then we've got the load going to the light. Then the light needs the neutral wire, which is connected to the supply. But because the day-night switch has an electronic circuit, the electronics also need current or voltage to operate, so it needs a supply. That is why the day-night switch also requires a neutral wire. The day-night switch requires the neutral wire to power up the controller inside, which controls this relay. Therefore, the day-night switch also has a connection to the neutral. And this is precisely why day-night switches have three wires. Over here I've got three terminals. Right, just going through some basics quickly. A normal light circuit with a supply. There's my AC supply, live, neutral. There's my light, and we can see that the light is connected across the supply. Current can flow into my light. Now, if I add a switch to that circuit, the light will only energize. If the switch is closed, then I'll have current flowing through the light. Then I'll be able to see the floodlight go on. Now, in the case of a day-night switch, the thing that is controlling that switch is the amount of sunlight, which is measured, and a relay opens and closes contacts in order to switch on the light or switch off the light. Right, so I'm now going to wire it up, and I will be referring to this diagram as I go. Now, the first thing we need is a supply. Some people are going to opt for just a plug-in solution where they have a plug, almost an extension cord of sorts, the day-night switch, and then it is fed to their light. That's one way to do it. Another way, which is probably more common, would be to wire directly from the circuit breaker. You might have installed a circuit breaker specifically for outdoor floodlights. Now over here I've got three circuit breakers. Over here, this is a 32 amp circuit breaker. Now, just in terms of selecting the circuit breaker, the size of the circuit breaker is extremely important, because I couldn't possibly use this 32 amp circuit breaker with just this 10 amp load. This circuit breaker's current rating is way too high for this type of load. Also, I now need to specify the wire size. Now, for a small little load such as this floodlight, 10 watt, or even a 50 watt floodlight, I still do not need a high current circuit breaker. I would need a much smaller circuit breaker. Over here I've got a different type of circuit breaker. The rail is different. It operates in the same fashion. It's just that this is for a Samite rail, while this is for a DIN rail. So you might find your circuit breakers do not look exactly like this. What we are looking at is the current rating. So over here I have a 10 amp circuit breaker. This would be sufficient. Even smaller, a 6 amp, also fine for a small floodlight. If I'm going to have lots of floodlights, I will just use a 10 amp circuit breaker. And the reason being is, even though this floodlight says 10 watts. It is an LED floodlight and it has a bit of a capacitive charge when it turns on, and therefore one has to acknowledge that there is an inrush current when we turn on the light. Specify the circuit breaker based on the inrush characteristics of the floodlights. I've covered this in a lot more detail towards the end of the video. Now, specifying the wire for the circuit breaker is extremely important. In this case, this is a 10 amp circuit breaker, and if it's for a 220 or 230 voltage supply, I can easily use a 1.5 millimeter wire. I can go slightly thinner. I can use a 1 millimeter wire. However, there are rules about how long the cable run can be and whether the cable run is on the surface or if it's in the sun and things like that. You would need to consider your local standards in terms of the wire thickness. I'm just demonstrating that the wire size is extremely important when specifying the circuit breaker. Right, so in this case, my cable run is less than 20 meters. It will be run in the ceiling, and I'll be using a 1.5 millimeter wire with a 10 amp circuit breaker. Right, then there is a neutral wire. As I said, the circuit needs a neutral wire. Now the neutral will be connected to the neutral rail, so you will need to connect to the same neutral rail of the phase you are working with. If your supply is a single phase, you'll only have one neutral bus bar. Right, so once you've sorted that part out, now we have the supply coming from the circuit breaker. So the live would be connected there, the neutral would be connected from your bus bar, and then we will now feed it to a junction box. Now in this video, the live is going to be considered red and the neutral is black. In your country, it may be different. Now on the light fitting side, the brown is the live and the blue is the neutral. I understand that in different countries they use different color wires, so I'm really just focusing on the principle here. So in my video, the red is live and the brown is live. The neutral wire is black or blue. The earth wire is the bare copper or the green and yellow conductor. Right, referring back to the diagram, you can see that from the supply I've got a live and a neutral. Right, here we go. I've got my live and my neutral coming from the supply. The earth is standard across the whole unit. So I'm not too worried about the earth at this moment. Now notice that this is a junction. So what I'm going to do is I'm going to have a junction over there. So I'm going to have my supply wires coming in there. I'm then going to have my light fitting wires. So my light fitting wires are going to go there, and then I'm going to have the wires which are going to be wired to my day-night switch. That is why I'm using a three-way junction. Now in every country they use different types of junctions or couplers. Now over here, this is a gland which slides in here to make it watertight. I'm not going to put the gland in for now. I want to demonstrate the wires going to the day-night switch, so that is why I'm leaving that open for now. Right, so on the left-hand side, I have the supply coming in. On the right-hand side, I've got the wires for the light fitting, the light, and then I need to wire it to my day-night switch. In this case, there are 3 terminals over there. On this day-night switch, there are 3 terminals. Notice it says live, so there's the live. Then it says N for neutral. Then it says A for appliance or load. Notice that the A is linked via the load to the neutral. So I can imagine this is quite confusing for many people, right? So all I need to do is have 3 wires. Notice there's 3 terminals there, so I just need to have 3 wires coming in here. I'll have my live, neutral, and my live for my load, which is my light. So over here I have my 3 wires. A neutral wire, in this case, is going to be black in color. As I said, I'm in South Africa. I use black for the neutral. Then I have 2 live wires. Notice that the live coming from my supply, there's L, and then for the load, which is actually also a live wire, I've just put a yellow tape around both sides so I know which one of these wires is the one for the load. So the one with the yellow tape means it's for my load. If you can get different color wires. You can get purple, you can get lots of different colors. You can get 4-core cable, and you'll have 3 different colors and an earth depending on what you choose. Right, now I need to thread this through here. I could put in a screw-in gland. For example, want it to be watertight. Now obviously I can't have the wires bare like this. Now the law requires that the wires have to be covered. I can't have the wires sitting out like this in the air. So in your case, you would have bought a 3-core cable, or you could use a sprag. but the point is the wire must be covered. So I'm just going to show you the principles here. Now these wires would go in here, and I'm keeping it open specifically for explanation purposes. Right, so I've now wired a live, a neutral, and a load wire. These are coming through into my little junction here, and now I'm going to wire this all together. Right, having the diagram nearby, we can see that all the neutrals are tied together. So the neutral of the light, the neutral of the day-night switch, and the neutral of the supply all together. That means my black wire and my blue wire are together because those are the neutrals. Right, so in the meantime, I've got all my neutrals together. There's the neutral from the light. In this case, the light's neutral happens to be blue. Then I've got the neutral from the supply coming from the AC source. And then I have the neutral, which is going to feed the day-night sensor. There's the black wire, there's the neutral. All the neutrals tied together. Now it says live V in to my day-night switch. So this is my live going to my day-night switch. It said live on the day-night switch, and it needs to go to the supply live. So that is this wire over here. Now the output from my day-night switch, which said load or appliance, notice that that is the live wire to my light. So my light, there it is, there is the live wire, which is brown. I need to take it to the day-night switches load or live output wire. Lastly, in this case, there's an earth wire which came with my supply wire, and there is an earth wire because my light fitting has a metallic surface. So I do need to connect the earth to the earth. Some light fittings do not have an option for an earth wire, so in that case you can just omit the earth wire. Right, now that all the wiring has been done, you can join the wires together using terminal blocks such as these. Unfortunately, these do rust after a while. Also, the wiring standard specifies that if a screw has to come through and fasten onto a wire, it must not separate the strands. And because this is stranded wire, it would separate it. So I'd have to have bootlaces here in order to use this if I wanted to do it correctly. It is much better to use ferrules and then crimp them. So say for example, I have my ferrule here, I will just insert it. And then I would just crimp each one of these ferrules. Then I would just insulate these so these cannot touch each other. Then I would put these inside and put the cover on. Right, now I'll demonstrate it working. Right, I'm leaving mine open just for explanation purposes. There is a shock hazard now when I energize this, so obviously please be very careful. Right, so over here I've got my meter and I'm just demonstrating it. The power is now on, just checking the power from the supply. That is my neutral, and then my live over there. Notice the voltage is at 228 volts, but notice that the LED floodlight is off. The reason it is off is because there's too much light around the sensor. There is the LDR, there's too much light over here, so I'm going to close the lid here. It does come with this little black plastic bag which I can put over here. I'm just going to cover it with this box. Right, so I've covered it with the box and immediately the light came on, and obviously if I measure the output by the light, notice that the light now gets the 228 volts because the day-night sensor is in the closed position. When the sun comes up in the morning, it will then go off. There you can see it has now disconnected the day-night switch. There is a little delay. Please note that even though the day-night switch is in the off position, the light is off, there is still a significant voltage here, 228, and the same is true at the day-night switch. If I measure at the day-night switch the live and the neutral, you'll see there is the voltage, 228 volts. If I measure the neutral and the output, the load of the day-night switch, you can see that there is a voltage there, but it's not enough to energize that light. All right, so there you go. That is how you wire your day-night switch. Now, if you wanted to add additional lights connected to the same day-night switch, for example, if you wanted to add another light fitting or another floodlight, I'll quickly show you the wiring diagram for that. Right, so if I wanted to add another load, all I needed to do is connect the live wire to the live on this side on the output of the day-night switch, and then I can connect the neutral to that same neutral wire. So I'm effectively connecting it in parallel. I can do this a few times as long as I do not overload the day-night switch. In this case, my day-night switch is rated at 25 amps, but keeping in mind that you are limited by the current rating of the circuit breaker and the wires that you have used. If you've used thicker wires and your circuit breaker is of a higher capacity and your day-night switch can handle, in this case 25 amps, you can put quite a few floodlights and you won't overload the system because your circuit breaker and your wires are matched to the load that you require. So just giving you an example here. So here are two lights. Just noting the live and the live would be connected to each other, the neutral and the neutral would be connected to each other, and the earth and the earth would be connected to each other. So this is like now one bigger load. Right, now in closing, I'm going to quickly describe some of the turn-on characteristics of globes. This is important for specifying the wire size for your circuit as well as the circuit breaker. Right, according to the SANS 10142 standard, it states that CFL lighting, where installed, must be considered at double the sum of the lamp watts. What that means is, say for example, you use the compact fluorescent lighting and say for example it is rated at 14 watt globes, we would then consider each globe to be 28 watts. Why that's important is when you are choosing the conductors for your lighting circuit, you will then base it on double the lamp load. Also important is the power factor correction. If there is no power factor correction, lamps such as discharge lamps, which are the sodium and the mercury vapor, they can use as much as 64% higher current than what is rated on the body of the unit. So very important is the power factor correction. Now, there is something else called inrush current. This is the sudden increase in current when we turn on lights. This is specifically true for LED lighting, which has a very high inrush current versus nominal current. So nominal current, this is the current that flows under normal conditions once the light has already turned on. Now, because LED lights generally use a LED driver circuit, these LED driver circuits use a capacitor. A capacitor pulls a high current when it is charging. This current is also dependent on the phase angle of the voltage at the time when you turn the power on. So say for example you turn the power on and it just so happened that the voltage was at 90 degrees, well then you're going to have a very high inrush current. If you turned on the power at close to the zero crossing, then your inrush current is significantly lower. This is out of our control. There are circuits that you can get to delay the turn on to make sure that it turns on the lights at a zero crossing, but generally people do not have these things and they just install LED lights and then they install too many, and what they found is the circuit breaker trips. I'm going to quickly go through some things to consider. Now over here I've got a diagram for a miniature circuit breaker rated at 10 amps. Now what we're seeing on the bottom axis is the LED driver rated power. So say for example you're using a 10 watt LED floodlight or maybe a 30 watt. So the wattages are shown at the bottom. Then on the vertical axis, we got the maximum number of LED lights that you may install on one circuit. And these lines here represent the different curve types for different circuit breakers. What that is different circuit breakers follow different short time characteristics. What that means is when there's a short circuit, we can see that certain circuit breakers operate quicker. Here is the time that the circuit breaker would operate, and this is the percentage or the times rated current. So at 4 times the rated current, this circuit breaker following a B curve would operate at about 5 milliseconds. Why this is important is as follows. So if you have chosen 30 watt LED floodlights and you're using a 10 amp circuit breaker, you're limited to only, let's say, 11 floodlights in total. Now that may seem very little, because consider that 30 watts times 11 is only 330 watts. Let's just say, for example, the power factor is 0.9. That is only about 366 watts. If the circuit breaker is 10 amps, one would think that you could say, well, 10 amps times the voltage, which is 230 volts, times a power factor of, say, 0.9, we should be able to get a capacity of 2070 watts. And if I divide that by 30, we should be able to get 69 LED floodlights. But unfortunately, we'll only get 11. And the reason for that is because of this inrush current. This inrush current for LEDs is in most circumstances more than 10 times the nominal current. And yes, it can even be 40 times and 50 times the nominal current. And because of that, to consider it, and therefore we can only install fewer, even though the running current is so much lower than the circuit breaker's maximum capacity. So these are some things to consider, just keeping in mind that always follow what the manufacturer or the circuit breaker's data sheet says. This diagram here is a general diagram and does not apply across every circuit breaker. Most important is please consult the circuit breaker's tripping curves of the breaker that you have. Alright, for more details on this, please check out my videos in my electrical tutorials playlist. I will also put a link below. Thanks for watching and cheers.